Hello my dear friends, welcome to Venus EduTech. In this video we can discuss exercise 2.3 workout questions. So without wasting time, let's get into the video. So the first question is to divide the polynomial p of x by the polynomial g of x, where p of x is the dividend and g of x is the divisor, and find the quotient and remainder in each of these following cases. And the first question, here it is, the polynomials are p of x equal to x cube minus 3x square plus 5x minus 3 and g of x is equal to x square minus 2. So we can perform the polynomial division. See, here it is x cube minus 3x square plus 5x minus 3 divided by g of x is x square minus 2. Now we can perform the polynomial division. I am not explaining in detail how to divide step by step, that we all discussed in our previous videos. So first one, x square into x, it is x cube. Then minus 2 into x, it is minus 2x. So write it under the x term, minus 2x. And here x square term is 0. Okay. Now minus 3x square, here it is 0x square. So by subtracting we will get minus 3x square. Then plus minus of minus, it becomes plus. So plus 7x. Then this minus 3. Now the degree of this remainder is equal to that of the degree of the divisor. So we can continue the division process. X square into minus 3, it is minus 3x square. Minus 3 into x square, it is minus 3x square. Then minus 2 into minus 3, it is plus 6. It's a constant term, plus 6. So write it under the constant term. Here x term is 0. Now 7x. Then minus 3 minus 6. It becomes minus 9. Now look, the degree of the remainder is less than that of the degree of the divisor. So we have to stop the division process. So what is the quotient for this particular polynomial? Quotient is equal to x square minus, not x square, it is x minus 3, and remainder is equal to 7x minus 9. Got it? Going to the next question. P of x is x raised to 4 minus 3x square plus 4x plus 5, and g of x is x square plus 1 minus x. And notice that here g of x divisor is not in the standard form. So write it in the standard form, x square then minus x plus 1. Now we can perform the division process. So x raised to 4, here there is no x cube term. So we can write 0x cube. Then minus 3x square plus 4x plus 5 divided by x square minus x plus 1. Okay. X square into x square, it is x raised to 4. Then minus x into x square, it is minus x cube. Then plus 1 into x square, it is x square plus x square. Now do subtraction. Here x raised to 4 and x raised to 4 get cancelled. Then 0 and minus 1. 0 minus 1. We are subtracting. So minus minus becomes plus. 0 plus 1. What is the answer? 1. And here it is x cube term. So 1x cube, or simply we can write it as x cube. Okay. Then what about the x square term? It is minus 3 x square plus x square, right? Minus 3x square and x square. We are subtracting. So minus 3 minus 1. Simply x square means it is 1x square, right? So minus 3 minus 1, it is minus 4. So this becomes minus 4x square. Then write the remaining terms, plus 4x plus 5. Now check whether the remainder is 0. No, the remainder is not 0 and its degree is higher than that of the degree of the divisor. So we can continue the division process. X square into x. X plus x. X square into x, it is x cube. Then what about minus x into x? It is minus x square. Minus x square. Then plus 1 into x, it is plus x. Then subtract. Minus 4 minus 1. We are subtracting. So minus 4 minus minus becomes plus, plus 1. Minus 4 plus 1, it is minus 3. So minus 3x square. Then what about x term? 4x and x. That means plus 4 and plus 1. We are subtracting. 4 minus 1, it is 3. So plus 3x. Then here the constant term is 0, right? Plus 0. That means 5 minus 0, it is 5. Got it? Now the degree of the remainder is equal to that of the degree of the divisor. So we can continue the division process. X square into dash is minus 3x square. Minus 3 into x square it is minus 3x square. Then minus x into minus 3 it is plus 3x. Minus minus becomes plus. Minus x into minus 3 it is plus 3x. Then 1 into minus 3 it is minus 3. Now this term get cancelled and 3x also get cancelled. Then constant terms 5 and minus 3 we are subtracting. So 5 plus 3 it is 8. So we got the degree of the remainder less than that of the degree of the divisor. So we can stop the division process. So what is the quotient here? Quotient is equal to x square plus x minus 3 and remainder is equal to 8. Now the third question is p of x is x raised to 4 minus 5x plus 6 and g of x is 2 minus x square. And this is not in the standard form. So we have to write in the standard form minus x square plus 2. Now we can perform the division. Here it is x raised to 4 and after 4 it is x raised to 1. No x cube and x square term. So we can write simply as 0x cube plus 0x square then minus 5x plus 6 divided by, which is the divisor, minus x square plus 2. So minus x square into minus x square it is x raised to 4, right? Minus minus becomes plus and x square becomes x raised to 4. So x raised to 4 then plus 2 into minus x square it is minus 2x square. Okay. Now subtracting. Here no x raised to 4 term, no x cube term, and what about x square term? 0x square and minus 2x square we are subtracting. So minus minus becomes plus. So 0 plus 2 x square. 0 plus 2 it is 2. So 2x square. Then here it is 0x, right? Here also 0. So just write the remaining terms minus 5x plus 6. Now do the division. Why? We are continuing the division because the degree of the remainder is equal to that of the degree of the divisor. Now minus x square into minus 2 it is plus 2x square, right? Minus 2 into minus x square it is plus 2x square. Then what about this one? Plus 2 into minus 2 it is minus 4 and it should under the constant term. You have to write it under the constant term. This becomes cancelled. It becomes 0. And what about x term? Minus 5 and 0, right? Minus 5 minus 0 it is minus 5 itself. So minus 5x. Then 6 minus of minus 4. 6 plus 4 it is 10. Plus 10. Minus 5x plus 10. Now the degree of the remainder, that is 1, which is less than that of the degree of the divisor, that is 2. Okay, so we can stop the division process. So what is the quotient? Quotient is equal to minus x square minus 2 and remainder is equal to minus 5x plus 10. And here we can take minus as common, so that minus of x square plus 2. Now the second question is to check whether the first polynomial is a factor of the second polynomial by dividing the second polynomial by the first polynomial. So we can look into the questions. So the first question is this one. We have to check whether this polynomial is a factor of the second polynomial by finding how? By dividing the second polynomial with the first polynomial. So we can do the polynomial division. We all know. So the polynomial is 2t raised to 4 plus 3t cube minus 2t square minus 9t plus, not plus, it is minus 12 divided by, this is the dividend. And what about the divisor? It is t square minus 3. Now taking the first term, t square into 2t square, it is 2t raised to 4, right? So t square into 2t square, it is 2t raised to 4. Then minus 3 into 2t square, it is minus 6t square. So write it under the t square term, minus 6t square. Then do the subtraction. So here it becomes 3t cube. Then minus 2t square minus 6t square. We are subtracting. So this minus minus becomes plus. So minus 2t square plus 6t square, it is 4t square. So plus 4t square. Then write this one minus 9t minus 12. Now again do the division. Why? Because the degree is higher than that of the divisor, right? So t square into 3t it is 3t cube. So plus 3t into t square it is 3t cube. Then minus 3 into 3t it is minus 9t. So write it under the t term. Do the subtraction. So here it becomes 4t square minus 9t. Here it becomes plus. So get cancelled. T term get cancelled. Then minus 12. Now again we can perform the division because the degrees are equal. T square, t square. So t square into 4 it is 4t square, right? So plus 4 into t square it is 4t square. Then minus 3 into 4 it is minus 12. So here the remainder is 0. That means this polynomial is a factor of this polynomial. So if the remainder is 0, we can conclude that the first polynomial t square minus 3 is a factor of the polynomial 2t raised to 4 plus 3t cube minus 2t square minus 9t minus 12. Going to the next question. The first polynomial is x square plus 3x plus 1. We have to check whether this is a factor of this polynomial. By how? By dividing this polynomial with this polynomial. So 3x raised to this one is the dividend and this is the divisor. We can perform division. So x square into 3x square it is 3x raised to 4, right? So 3x square into x square it is 3x raised to 4. And what about the next term? 3x into 3x square it is 9x cube plus 9x cube. So write it under the x cube term. And what about the third term? 1 into 3x square it is 3x square, right? So write it under the x square term. Now perform subtraction. So 5x cube minus of 9x cube. What is the answer? Minus 4x cube, right? Then the next term minus 7x square minus 3x square, it is minus 10x square. Then write the remaining terms plus 2x plus 2. Now we can perform division because here the degree is x cube and here it is x square. That means the degree is higher on this side. So we can perform division. X square into minus 4x, right? Minus 4x into x square, it is minus 4x cube. So write here. Then what about the next term? Plus 3x into minus 4x, it is minus 12x square, right? Yeah, minus 12x square. And what about the other term? Plus 1 into minus 4x, it is minus 4x. Now perform subtraction. What is the result? Here minus 10 plus 12. So it is 2x square. Then 2x plus minus minus becomes plus. So 2x plus 4x, it is 6x. Plus 6x plus 2. Now again we can perform division because here the degree is x square, here also the degree is x square, the degrees are equal. So plus 2 into x square, it is 2x square, right? And what about 3x into 2, it is 6x. So plus 6x. Then next 1 into 2, it is 2 plus 2. So here the remainder is 0. Since the remainder is 0, we can say that the first polynomial, that is x square plus 3x plus 1, is a factor of 3x raised to 4 plus 5x cube minus 7x square plus 2x plus 2. Going to the next question. X square minus 3x plus 1. We have to check whether this is a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. And here there is no x raised to 4 term. So put 0 x raised to 4 here. We put 0 because there is no x raised to 4 here. So we can perform the polynomial division now. So x square into x cube, it is x raised to 5, right? X square into x cube, it is x raised to 5. How? X square into x cube, it is x raised to 5. Why? Because we know that the formula x raised to m into x raised to n is equal to x raised to m plus n. And here m is 2 and n is 3. So m plus n means 2 plus 3, it is 5. So x square into x cube, it is x raised to 5. Then minus 3x into x cube, it is minus 3x raised to 4. So minus 3x raised to 4. That's why we put 0x raised to 4 here, because we have a term while multiplying this. So we put, or we wrote minus 3x raised to 4 under this x raised to 4 term. Then again minus 3x into x cube, it is minus 3x raised to 4. Then 1 into x cube, it is x cube plus x cube. And performing the subtraction, what we will get? 3x raised to 4 by 0 minus of minus. So minus minus becomes plus. We will get 3x raised to 4. Then minus 4 minus 1. It is minus 5x cube. Then plus x square plus 3x plus 1. Now again here x raised to 4, here x square. So degree is higher on this side. So we can perform the division. X square into 3x square, it is 3x raised to 4. 3x square into x square, it is 3x raised to 4. Then minus 3x into 3x square, it is minus 9x cube. Minus 9x cube, write it under the x cube term. Then plus 1 into 3x square. 1 into 3x square, it is 3x square. Write it under the x square term. Now performing subtraction, what we will get? Minus 5 plus 9, it is 4. 4x cube. Then 1 minus 3, it is minus 2. Minus 2x square plus 3x plus 1. Again x cube, x square. Here degree is higher, so we can perform division. X square into 4x. Why? Because 4x into x square, it is 4x cube. So write 4x cube here. Then minus 3x into 4x, it is minus 12x square. Minus 12x square, write it under x square term. Then plus 1 into 4x, it is 4x. Plus 4x. Performing subtraction, what we will get? Minus 2 plus 12, it is 10. 10x square. 3 minus 4, it is minus 1. Minus x plus 1. Again, x square into dash, it is 10x square. 10 into x square, it is 10x square, right? So plus 10 into x square, it is 10x square. Then minus 3x into 10, it is minus 30x. Minus 30x. Then plus 1 into 10, it is 10. Plus 10. So what is the remainder? Minus 1. Performing subtraction, minus 1 plus 30, it is 29x. Then plus 1 minus 10, it is minus 9. 29x minus 9. Here the remainder is not 0 and the degree of this remainder is less than that of the degree of the divisor. So we cannot perform division further. So what we conclude? We can conclude that x square minus 3x plus 1 is not a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. Why? Because the remainder is not 0. Doing the similar one, x raised to 5 minus 4x cube plus x square plus 3x plus 1 divided by x cube minus 3x plus 1. We have to check whether this is a factor of this polynomial. So carry out the division process. X cube into x square, it is x raised to 5. Then minus 3x into x square, it is minus 3x cube. Write it under the x cube term. Then 1 into x square, it is x square. So minus 4 plus 3, it is minus 1. So minus x cube. X square get cancelled. Write the remaining one, plus 3x plus 1. Now, my x cube into minus 1, it is minus x cube, right? So minus 1 into x cube, it is minus x cube. Then minus 3x into minus 1, it is plus 3x. Plus 3x. Again, plus 1 into minus 1, it is minus 1. Minus 1. Now doing subtraction. Here this term get cancelled. This term also get cancelled. Here 1 minus of minus 1. 1 plus 1, it is 2. So here the remainder is 2. Not equal to 0. Here the remainder is 2, which is not 0, and also its degree is less than that of the degree of the divisor. Here x cube minus 3x plus 1 is not a factor of x raised to 5 minus 4x cube plus x square plus 3x plus 1. Why? Because the remainder is not 0. If it is 0, then we can say that this one is a factor of this polynomial. But here the remainder is not 0, so we can say that this is not a factor of this polynomial. Next question. Obtain all other zeros of this polynomial, that is 3x raised to 4 plus 6x cube minus 2x square minus 10x minus 5 if two of its zeros are root of 5 by 3 and minus root of 5 by 3. So how we will obtain this? It's given that two of its zeros are plus root of 5 by 3 and minus of root of 5 by 3. So that means plus root of 5 by 3 is one of its zeros of this polynomial. That means x minus of root 5 by 3 is a factor of this polynomial. And again, the other 0, it is given that negative of root of 5 by 3. That means x plus root of 5 by 3 is a factor of this polynomial. Understood? So it is given that two of the zeros of this polynomial are root of 5 by 3 and negative of root of 5 by 3. So root 5 by 3 is a 0 of this polynomial. That means x minus root of 5 by 3 is a factor of this polynomial. Again, the other 0 is negative of root of 5 by 3. That means x plus root of 5 by 3 is a factor of this polynomial. Now, look at this. This is of the form a minus b into a plus b. And what is a minus b into a plus b? It is a square minus b square. Here a it is x. So a square, x square minus b square. Here b it is root of 5 by 3. So the whole square it becomes 5 by 3. So x square minus 5 by 3. That means x square minus 5 by 3 is a factor of this polynomial. So how we will simplify this? Which is equal to 3x square minus 5 by 3. Right? Which again can be written as taking 1 by 3 outside, so that it becomes 1 by 3 into 3x square minus 5. Understood? That means both 1 by 3 and 3x square minus 5 are factors of this polynomial. So the question is to find all other zeros. 2 of its zeros are given. We have to find the other zeros of this polynomial. How we will find? We will find it by dividing this polynomial by 3x square minus 5. So performing polynomial division, 3x square into x square it is 3x raised to 4, right? 3x square into x square it is 3x raised to 4. Then minus 5 into x square it is minus 5x square. Performing subtraction, so 6x cube. Then minus 2 plus 5 it is plus 3. Plus 3x square minus 10x minus 5. Then again here the degree is higher than that of the divisor, so we can perform the division. Then 3x square into dash it is 6x cube. 3x square into 2x, right? So plus 2x. 3x square into 2x it is 6x cube. Yes. Then minus 5 into 2x it is minus 10x. Minus 10x. Then subtracting 3x square minus 10 plus 10. It becomes cancelled. So write this one minus 5. 3x square minus 5. Here 3x square minus 5. Here also 3x square minus 5. So plus 1 3x square minus 5. Because 3x square minus 5 into 1 it is 3x square minus 5. Here the remainder is 0. So we got the factor x square plus 2x plus 1. So the question is to find all other zeros. So we got the quotient, right? X square plus 2x plus 1. Now how we will find its zeros? By splitting the middle term. We know how to split the middle term. We studied in our earlier classes. Okay. So we can perform the middle term splitting method. That is x square plus 2x plus 1. How? Do you know x plus 1 the whole square, the identity? Using the identity a plus b the whole square, we know a plus b the whole square it is a square plus 2ab plus b square, right? So here x plus 1 the whole square is x square plus 2x plus 1, the same one. So here we can directly write it is equal to x plus 1 into x plus 1. Why? Because x plus 1 the whole square is x square plus 2x plus 1. Or if you don't know or if you don't remember the identity, you can do it by splitting the middle term. How? X square plus 2x can be written as x plus 1. Then taking the common factors, x into x plus 1 into x plus 1, which is equal to x plus 1 into x plus 1, which is nothing but x plus 1 the whole square, right? So here x plus 1 is equal to 0 implies x is equal to minus 1. Here x plus 1 is equal to 0 implies x is equal to minus 1. So its other zeros are x is equal to minus 1 and x is equal to minus 1. So its zeros are root of 5 by 3, minus of root of 5 by 3, then minus 1, minus 1. Moving on to the next question. On dividing x cube minus 3x square plus x plus 2 by a polynomial g of x, the quotient and remainder were x minus 2 and minus 2x plus 4 respectively. Find g of x. How to find g of x? We know the formula dividend is equal to divisor into quotient plus remainder, right? So we know this formula, dividend is equal to divisor into quotient plus remainder, where this dividend is p of x, divisor is g of x, quotient is q of x and remainder is r of x, right? So we can perform or we can find g of x using this equation, which is that equation dividend. Here dividend of p of x, the polynomial, is x cube minus 3x square plus x plus 2. Right? Here p of x or the dividend is x cube minus 3x square plus x plus 2, and which is equal to, dividend is equal to divisor. Divisor it is g of x, we don't know, into quotient. Quotient is x minus 2 plus remainder. Remainder it is minus 2x plus 4. Minus 2x plus 4. Here it is given us respectively. That means the quotient is x minus 2 and the remainder is minus 2x plus 4. So perform how to find g of x. Here x cube minus 3x square plus x plus 2 is equal to g of x into x minus 2. We can move this remainder term to this side, left hand side, right? So here it is minus, here we cannot move because g of x into x minus 2 it is one term, divisor into quotient. So perform minus 2x plus 4 to this side. So what we will get, minus 2x becomes plus 2x and plus 4 becomes minus 4, which is equal to g of x into x minus 2. Right? Now x cube minus 3x square, here x term, plus 2x plus x, it is plus 3x. Then here constant term. So plus 2 minus 4 it is minus 2 is equal to g of x into x minus 2. Now how we can find g of x? From here we can find g of x by dividing this by this one. That is g of x is equal to x cube minus 3x square plus 3x minus 2 divided by x minus 2. So on performing polynomial division we will get g of x. So x into x square it is x cube. Then minus 2 into x square it is minus 2x square. Performing subtraction, minus 3 plus 2 it becomes minus x square, minus 1. Minus x square plus 3x minus 2. Then x into minus x it is minus x square, right? So minus x into x it is minus x square. Then minus 2 into minus x it is plus 2x. Plus 2x. Then subtracting we will get here 3 minus 2 it is 1. That is x minus 2. Here also x minus 2. Plus 1, right? Why? Because x into 1 it is x and minus 2 into 1 it is minus 2. Here the remainder is 0. That means the g of x we got x square minus x plus 1. That means when we divide x cube minus 3x square plus x plus 2 by this g of x, x square minus x plus 1, we will get the quotient as x minus 2 and the remainder as minus 2x plus 4. So the required g of x is x square minus x plus 1. Next question. Give examples of polynomials p of x, g of x, q of x and r of x which should satisfy the division algorithm and degree of p of x is equal to degree of q of x. So we can write an example which should satisfy the division algorithm as well as should satisfy this equation, that is degree of p of x is equal to degree of q of x. Let us say p of x is equal to 2x square plus 2x plus 8. Let p of x be 2x square plus 2x plus 8 and g of x be equal to 2. So on performing division what we will get, 2x square plus 2x plus 8 divided by g of x 2. 2 into x square it is 2x square. Then performing subtraction we will get 2x plus 8. Again plus 2 into x. Plus 2 into x it is 2x. Then subtracting we will get 8. Then plus 4, right? So 4 into 2 it is 8, 0. Or simply we can divide x square plus 2x, not 2x square, right? So 2x square plus 2x plus 8 divided by 2. Cancelling 2 term or taking 2 outside. So what we will get, x square plus x plus 4. Taking 2 outside divided by 2. 2 get cancelled. X square plus x plus 4. That means here the quotient is q of x we got as x square plus x plus 4. And remainder as 0. R of x is 0. And here we have to satisfy degree of p of x equal to degree of q of x. What is the degree of q of x? X square, right? The degree of q of x is 2. And what about the degree of p of x? Degree of p of x is also 2. That means we satisfied the conditions. Degree of p of x is equal to degree of q of x and also it is satisfying the division algorithm as well. The second question, we should satisfy degree of q of x is equal to degree of r of x. So we can take the polynomial p of x as x cube plus x square plus x plus 1 and g of x as x square minus 1. So that when we perform polynomial division, what we will get the quotient and remainder. So x square into x it is x cube, minus 1 into x it is minus x, subtracting x square plus 1 it becomes plus 2x plus 1. Then x square into 1 it is x square, minus 1 into plus 1 it is minus 1. So here 2x, 1 minus of minus 1, 1 plus 1 it becomes 2, 2x plus 2. So here we got q of x as x plus 1 and r of x as 2x plus 2, right? So here the degree of q of x is 1, x raised to 1. So the degree of q of x is 1 and the degree of r of x is also 1, 2x raised to 1. That means degree of q of x is equal to degree of r of x. Second question, to satisfy degree of r of x is equal to 0. So we can write p of x be equal to x cube minus x square plus 2x plus 3 and g of x as x square plus 2. So on dividing, x cube minus x square plus 2x plus 3 divided by x square plus 2. So x square into x it is x cube. Then plus 2 into plus x it is plus 2x. So here minus x square, then this becomes 0 plus 3. Then minus 1 into x square it is minus x square, plus 2 into minus 1 it is minus 2. So 3 minus of minus 2, 3 plus 2 it is 5. So here we got r of x as 5, that means a constant. That means its degree is 0. So we proved an example which is having degree of r of x as 0. Okay. So now friends, we can look into the summary of what all we studied in this chapter. These are the points which are given at the end of this chapter in our textbook. So going to those points. First point we have studied, polynomials of degrees 1, 2 and 3 are called linear polynomial, quadratic polynomial and cubic polynomials respectively. Degree 1 it is called a linear, 2 it is called a quadratic and 3 it is called cubic polynomial. Then a quadratic polynomial in x with real coefficients is of the form ax square plus bx plus c, where a, b, c are real numbers with a is not equal to 0. This equation is very important because our next chapter, I think fourth chapter, is related to quadratic equation and it is of the form ax square plus bx plus c, where a, b, c are real numbers and a is not equal to 0. Then the third point, the zeros of a polynomial p of x are precisely the x coordinates, not y, it is x coordinates. The zeros of a polynomial p of x are precisely the x coordinates of the points where the graph of y is equal to p of x intersects the x axis. Next point, a quadratic polynomial can have at most 2 zeros and a cubic polynomial can have at most 3 zeros. At most means maximum. So a quadratic polynomial should have maximum 2 zeros and a cubic polynomial should have maximum 3 zeros. Next point, if alpha and beta are the zeros of the quadratic polynomial ax square plus bx plus c, then alpha plus beta is equal to minus b by a and alpha beta is equal to c by a. Whereas where a is the coefficient of x square, b is coefficient of x and c is the constant term. Sixth point, if alpha, beta, gamma are the zeros of the cubic polynomial ax cube plus bx square plus cx plus d, then alpha plus beta plus gamma equal to minus b by a, alpha beta plus beta gamma plus gamma alpha equal to c by a, and alpha beta gamma equal to minus of negative of d by a, where a is the coefficient of x cube, b is the coefficient of x square, c is the coefficient of x and d is the constant term. And the last point, the division algorithm states that given any polynomial p of x and any non-zero polynomial g of x, there are polynomials q of x and r of x such that p of x is equal to g of x into q of x plus r of x, where r of x, the remainder, can be either 0, r of x is equal to 0 or its degree of r of x is less than degree of g of x, where p of x is the dividend, g of x is the divisor, q of x is the quotient and r of x is the remainder. Remember, r of x should be either 0 or its degree should be less than the degree of g of x or the divisor. Okay, fine. That's all for today's video. If you like my classes, Please share the classes or videos with your friends who are preparing for class 10 exams, and don't forget to subscribe the channel. Press the bell icon as well to get notification of my latest videos. See you in the next video with another useful topic. Till then, have a good day and thank you.